I think we can start. So the goal, just quickly introduce the SIG. So the SIG on spoken language translation. So we started our activity a couple of years ago. The president of the SIG is Professor Nakamura from NICE Institute, and I am the secretary. And the goal of the SIG is to try to attract people working in spoken language translation with very large identification of the term. Because today we have a sign language, but we can have also something on speech, ASR, and so on and so forth. So, and the idea is to have these seminars where we touch different topics. And our idea was mainly to let young researchers to present their work, and but sometimes we have also senior scientists like Dimitar and Mirella, and we are very excited to have them on board. So today we are talking about sign language. We have two speakers. This is exceptional for us because we have one, and we have Dimitar Shterionov, who is assistant professor in the Department of Cognitive Science and Artificial Intelligence at Tilburg University, and he's the coordinator of the largest sign language project never found in the EU, and the name is Sign On. So he has Dimitar has a lot of activity in different aspects of NLP, in particular machine translation with quality estimation, automatic post-editing, speech-to-text, text-to-speech, and so on and so forth. Mirella, who is postdoc in the same department, she's a member of the Sign On project, and her research mainly focuses on sign language machine translation and how to use and support the system with linguistic information, let me say. So the title of the lecture today is State of the Art and Current Challenges in MT for Sign to Speak Languages. And now I leave the floor to Dimitar and Mirella. And I mean, usually we have 45 minutes, but we are late, so take your time and it's up to you. You prefer to have questions at the end or during the presentation? It's really up to you.
Okay, thanks, Mark, for the introduction. So I'll share my screen. Is that okay?
Yeah. Sure, please.
That's us, myself, Dimitar, and Mirella from the other side. If you would like to contact us, you can do that via Twitter or email, and you can find us also on other social media, of course. So when Marco contacted me about this, I was thinking like, okay, so sign language, that's what we are doing now, mostly within the Sign On project. Why am I going to talk in front of the group on spoken language translation? Although our project involves spoken language translation, that's not my expertise. I'm not versed in this to talk about that. But then I was thinking, actually, sign language reveals so many challenges that actually it would be nice to introduce these challenges so that we, as a community working on translation, machine translation, or automatic translation, are aware of that, and thus bring communities closer together. There are parallels, I'm sure, between spoken and sign language processing, language processing. So perhaps we can learn from each other with that respect. And so today we're going to talk a bit about what has been done in sign language machine translation, and what are the challenges from a linguistic and from technical perspective as well. And then we can open for some discussion afterwards. Just to say briefly about the project is indeed Sign On, as Marco said, and you can find us via the website, which you can access through the QR code here. The basic idea of the Sign On project is to develop a platform for communication between deaf, hard of hearing, and hearing users. And to do so, we have like very straightforward processing pipeline where you input video, record your video where you sign, or you record an audio, or you type text, and this is translated into, again, text, speech, or sign language via an avatar. We are supporting or trying to support 5 sign languages and 4 spoken languages at the moment, but we are developing the whole framework as a updatable framework, so that later when the project is over, people can take this framework and adopt it to new languages, new language pairs, whether they are sign language or spoken languages. Yeah, as I said, 4 spoken languages and 5 sign languages, and we are focusing on deaf, hard of hearing, and hearing people as our users. And within the context of that, I'll talk now about sign languages, because I'm not sure how many of you are familiar with sign languages, and I certainly was not familiar about what sign language is before I started thinking about sign-on. And we may think that sign languages are actually there is only one sign language, but actually there are multiple sign languages. There are actually more than 300 sign languages all over the world. Sign languages are visual languages where the language is conveyed via the hands, the facial expression, the body. I think that in Irish Sign Language, they say that it is 60% hands and 40% the face. But also there are other parts like the movement of the mouth, which, so mouthing, can express certain meanings that based on the mouthing, the meaning of the sign can change. So if you do the same sign with your hand, for example, that can be a week in Dutch Sign Language, or a person, depending on what you pronounce. So there is this aspect as well. So these are the components of sign language. So hand shapes, hand movements, movement and place of the articulation. So things can happen far away or close to the body, depicting different aspects of what you want to express, to represent. You have also different orientations of the palm. Actually in ISL, again, in Irish Sign Language, there are 79 different types of hand shapes that you can have, and I don't remember exactly how many orientations. And of course, you have the facial expressions and the facial movements, which especially are linked to the emotion that you want to convey. But as I said, with mouthing, you can actually change the meaning of the sign that you're doing. Another thing that we need to think about is simultaneity, where things in sign language can happen in parallel. So basically, one hand can sign one thing, another hand can sign another thing, and then they in parallel can convey the message that you want to convey, actually. And also in sign language, it's as a visual language, as a visual field that you have. Things happen around the interlocutor, around the speaker or the signer, actually. So you can use the 3D space, which then implies that you can place things around you and refer to these things by just pointing to certain locations. And so basically, this creates a very complex framework for language, for conveying a message, which then is linked to the challenges that we'll talk about later. In sign languages, another thing that we need to think about is that you have 2 types of vocabulary. You have the established vocabulary, where you have, as in English, for example, you have words aligned with their meanings. There you have signs aligned with their meanings. But you also have the productive lexicon, where, for example, 2 or 3 people, so a group of people, decide for a certain sign to have a certain meaning. And that happens only within this conversation, and later on in another conversation, the same sign or expression can actually have a different meaning. That is another second thing of challenges, let's say, that or second factor of challenges that impacts the whole machine translation of sign languages. And maybe you can say, okay, you have sign languages as you have spoken languages, but for spoken languages, you have a written form that is very easy to process because you have a sequence of words, sequence of text that is there that we can actually put in an encoder. We can pass everything through and just encode everything, then decode it, and voila, we have a machine translation system. The thing is that for sign languages, we don't have an official established notation system. Notation systems, as I show here, there are several of them. There is a Stockholm notation, which I think is one of the earliest notation systems. You have sign writing and Hamnosis, which are Hamnosis is quite popular. It's developed by the group in Hamburg. Hamnosis stands for Hamburg Notation System. You have also Escritura Alfabética de Lengua de Signos Español, SEA, which is another notation system which is based on the characters in the Latin alphabet. And you have glosses. I have put glosses here as a notation system, although glosses are much more than that. But the reason will come a bit in a moment. I want to give you just an idea about these notation systems, how they look like. On top here, you see the Stockholm notation. Below, it's the Hamburg notation. And on the other side, you see the sign writing notation. Sign writing comes from a person that worked on dancing, and how this person was trying to figure out how to actually interpret dances or show how people to learn dances, and that actually migrated to the sign writing science actually, or notation. And the sign writing notation, it is.
Sorry, Dimitar, there is a question.
Yes, of course.
I think Adam, please go ahead and ask directly to Dimitar.
Okay, I joined late. I wasn't sure what the protocol was on this. So I was just wondering if these notation systems are cross-lingual across different types of sign languages, or are they for a specific sign language?
Yes, so they are language agnostic in a sense, because basically what you have there is representations of the hand movements, shapes of the face, the mouthing, and so on. So they capture syntactic information in a sense, but the way or the combination of different symbols is what encodes sound semantics.
And it's general enough to cover different sign languages.
Yes, yes.
So sort of the alphabets are in common.
Yes, yes.
Okay, thank you.
You're welcome. Yeah, as you can see here, I think that's the easiest one to kind of comprehend. You have the face, the facial expression of the signer, and you have the hands and how they are, what movements they do basically at a specific moment. And there are systems that are built for translation using sign writing, for example. However, one thing that you can notice here is that you have actually this three-dimensional structure, where you have hands on one level, movements another level, face on another level, and so on. And that, of course, is difficult to actually serialize, to create a sequence out of it. But there is work that has been done that uses sign writing as an intermediate representation that takes video, converts into sign writing, and then translates out of that. And then, by the way, indeed, if there are questions and if you want to interrupt me, please do so, and then I'll be happy to answer. Okay. So the other thing that I wanted to note here is that you have glosses, and glosses, indeed, glosses are like a notation that tries to capture some sort of meaning. And they have been extensively used to document or to annotate sign language videos. And that's why I have put them in the notation systems, although that's a bit of an abuse of notation. But so basically, there are a lot of data. There is a lot of data out there that is for sign language. Not that there is a lot of data to train machine translation systems, but that's another topic. but there is all the data that is there, and it is annotated, uses glosses. However, glosses, despite of the fact that they capture the meaning of what is conveyed as a meaning in the sign video or in the sign tutorials, and they are sequential, which actually allows us to use them in a, let's say, a standard machine translation system. What happens is that between the different languages that we have different glosses, and even between different corpora within the same language, glosses can actually be different. And so that creates another sort of difficulty when it comes to trying to reduce the complexity of sign language and put it into a framework that we can actually, or in a formalism that we can actually train machine translation systems with. Here I actually wanted to give you an example from the corpus NGT, where on the right-hand side you see the gloss annotation, and that's per time. And then underneath you have the well, the transcription, the translation actually of what they are talking about. The Corpus NGT website provides this kind of videos, and it's very interesting if you want to see how the data looks like. And of course, when you want to build a system, you have to decouple all this and put them in some sort of a framework to train your machine translation systems. But yeah, so these are glosses that correspond to this conversation here, and they are per time. So these are at the moment root A is what is happening, and then the later ones are below. As I said, it is difficult actually to use glosses, although they are the most stable, most informative that we have for the moment, because between different corpora, you may have different glosses for the same meaning, and certainly for different languages, you do have different glosses, which makes it difficult to actually build multilingual systems. And so that's a system, let's say, from gloss in one language to gloss to another language. Okay, and now to go to the questions that we actually have within the context of this presentation, and maybe actually a bit broader in the context of what we do in terms of machine translation for sign language, is the first thing is how should we represent sign language data for machine translation purposes? Which algorithms are currently the state of the art for sign language translation, and which data sets are used for which languages, and what are the properties of these data sets? And finally, how are current SLT models evaluated, and is this sufficient? So in one of the papers, so in the beginning, under the title, there were two papers that were mentioned. So the presentation is based on these two papers. In the first one, we actually reviewed 32 papers written in English that propose, implement, and evaluate sign language MT systems. We have actually excluded some of them. Actually, what we did is this research actually was done mainly from the University of Ghent researchers. So they took they Googled, or they searched through the whole database of IEEE, sorry, and got all papers that had sign language somewhere as keywords, and then filtered out a lot of the papers, some of them even for the reasons of being offensive to the deaf community. And so at the end, we ended up with 32 papers, which were then reviewed, and we drew some information about what is currently the state of the art. In answering the first question, so I spoke about the different notation systems that we have for sign language. But if we think about what actually sign language is recorded as, it's videos. And videos, they have frames, and each frame can represent a picture. And when we think about the common machine translation approaches, we have like this encoder-decoder architecture where you pass token after token, and you encode your sentence, and then you have a decoder that will generate token after token, the sentence. However, if you think about the same approach for sign language, taking a video as input and trying to do an end-to-end video to text translation, what will happen is that you actually have frame per frame versus token to token. Sorry, you have actually frame to token versus token to token. And frames are much more in a given utterance than tokens are in a sentence, which then creates another type of complexity problem. And that's about the granularity of encoding the sign language utterance. For that reason, the typical encoder-decoder architecture, the way that we perceive it for machine translation of written of spoken language, is not that suitable. So it says here, MT for sign to spoken language is a frame to text or frame to token task, which is actually much harder. Frames are very granular representations of sign language message, and they don't capture syntax nor semantics.
Sorry, Dimitar, just
Yes.
a curiosity. How is different from speech translation, where in input you have the audio, which as well the audio is very, let me say, the information is very diluted in a lot of small pieces. So it's very different from speech translation?
Well, I think that the main difference is on the details that you have in the sign language video. And I think that there are parallels with spoken language processing and translation, but I don't know exactly what differences there are. I have to look into that.
Okay.
Yeah.
Okay. Thanks.
You're welcome. But yeah, I mean, you're right that if you think about the sequence of things that are captured or the information that is captured in audio or video, they can be very well aligned in terms of kind of the granularity. I think that in sign language, the main thing is that, well, perhaps you have much more information, much more detailed information is encoded there. But so as I said earlier about the glosses, and well, basically, when we looked into the papers, glosses is the only semantic representation actually that is used in the current state-of-the-art systems that are built there. And the reason is indeed that when you look into sign language data, what you have is annotation with glosses, and not with hamnosis, and not with Stokoe notation, not with sign writing. So when we do data-driven MT, basically we need to use glosses because they are there, and we can kind of align the videos with the glosses. There are 4 ways of incorporating glosses into the machine translation pipeline. Basically, we can build gloss to text machine translation system, which just takes the glosses that are there and they are sequential, and then we can map them into a text. Of course, in that situation, you need some sort of a recognition that will take a video and will convert into gloss, or will extract glosses. Then you have sign to gloss to text, which is actually a pipeline of 3 components, like a sign recognition that goes into a gloss, then goes then to text, and then you have sign to gloss and text together. And of course, at the end, we have end-to-end systems that are signed to text directly. And as you can imagine, based on what I said earlier, these are the hardest systems, and their quality is actually quite low. I think that last semester, a student of mine was working on NGT, so Dutch sign language, end-to-end system, and he got something around 2 blue points with the transformer architecture. So
another question.
sure.
Is all this work designed at captioning, or is some of it done after the fact?
I couldn't hear you. I'm sorry. Can you repeat that?
Yep. So is all this work designed around captioning, real-time captioning?
No.
Or is it some of it done after the fact?
So most of this is actually after it's been converted into glosses, for example, or after it has been.
No, I mean, what is is there a real-time requirement? So that is the idea to use this for captioning, so that as someone is signing, the speech is coming out immediately, or do you take a video, process it, and an hour later you get the text?
Yes, that's the latter is the more suitable use case, because again, if you think about this, you have a lot of frames that need to be processed, and then if you have to actually do that one thing after, like one frame after another, it will be quite hard. I know that in the context of speech to text, you have this online speech to text systems, but most of these systems that we have reviewed are actually static. Thus, just you provide sign language, and then at the end you generate output on the whole sign language input.
Thank you.
No problem. And especially when it comes to gloss text, you need to do the recognition first of the sign into gloss, and then you can do the gloss to text. So basically, here are the two or the four architectures depicted. In the second one, you have the sign language recognition system, which actually has to be continuous in this sense that you actually generate the gloss. When the gloss is generated, then you can actually generate the text. So with that respect, here you have this continuous component, but in general, as you can see here, we have glosses. Then so we have first the one thing and then the other one, and then at the end we provide the result. And so the requirements, of course, for building an MT system for sign to text are, of course, you need some sort of processing and representation, which we said that it's one challenge. Then you need to have translation between sign and spoken language representations. And then, of course, the other thing is data. So the data, I think, is one of the main challenges that is kind of harming the research in that direction. And it's because there is not enough data. Like for NGT, I think we have around 70,000 sentences that are aligned with videos. And that actually is kind of not enough to build a real machine translation system. Even if we talk about low resource machine translation, where you have where you have to do some tricks to actually get things done, 70,000 is still a very small amount of data. And to go to the system that we have reviewed, so out of these 32 papers, we see that there is a lot of work done sporadically at the era of statistical machine translation, so up till 2014. And then when neural networks came, there is kind of a boost, and there are a lot more papers published here. Now, around that age, there was indeed some interest in sign language translation. People were trying to build gloss-to-text systems using SLMT systems, just as text-to-text. But now we have a lot of work done on neural-based systems. And here is an outline of what papers we have seen. Of course, there are some rule-based systems, RNN systems. There are also some rule-based systems here, as you can see on top. There are some transformer models, some actually with the transformer and the RNN comparison, there are no conclusive results actually. some claim that, well, based on the experiments, that transformers are better. In other cases, RNN seems to be actually better. Now, what is interesting in this situation is that somewhere here, the work of Kamgus used visual embeddings, visual representation, which actually could be fed together with text or with glosses to boost the performance of the translation. And using visual embeddings indeed seems to be the most kind of beneficial way to do machine translation. We have done in our work in the Sign-On consortium, we have done that as well using visual embeddings together with text and glosses. And indeed, that seems to be the best way to go about that. On the evaluation side, here are some results. And as you can see, when it comes to blue, we have scores around the 20s here. And these are works based on optimized or with optimized models that indeed integrate spatial temporal features together with other features as well, and so on. What I actually so these are the gloss-to-text works here, assigned to gloss-to-text, and then there are some sign-to-text here models. Now with the sign-to-text here models, what you can see here is that you have quite low scores. And as I said, when my student tried last year to work on Dutch sign language, the results were really horrible. Of course, we didn't do any optimization there. But basically, when you do an end-to-end representation, an end-to-end learning, that is actually not quite efficient. I will actually skip this because I want to give time to Mirella also to go to her side. But basically, just to wrap up here my part about which kind of sign language representations are most informative. Glosses certainly are the most informative because they come directly from the meaning and they are kind of sequential. You have also deep learning representation, which are also quite important, like the visual embeddings, and combining these together is actually quite a nice thing. Sign language data, as I said, we don't have so much data. There are some open data sets, but within Sign-On, we're collecting and processing data. And whatever data is possible to be released, we will do so that people can actually continue the research in this field. On the topic of evaluation, can we actually use Blue, Rouge, and Meteor? At the moment, yes, these are our standard metrics for machine translation, but what is important is to include human evaluators, because when it comes to sign language, we have seen within our consortium that how humans perceive whether it is the text or the sign, how well it is generated, it is really different from the automatic metrics. As it says here, only 1 out of the 32 papers actually was included human evaluators in this review that we did. And I'll skip this point because there is not so much time for Mirella. One other thing that I just wanted to note, as you can see, sign language translation involves a lot of components, a lot of knowledge about different things like video processing, linguistics, translation like neural networks, etc. So it's actually a very interdisciplinary research, and that's what we're trying actually to do in our consortium. And I think that that's for my part. Are there any questions?
I think let's move to Mirella's part, then in case we can have later some questions.
Yes, okay.
Okay, shall I share my screen now and go to the presentation, or do you want, okay.
You can do that. I think it will be easier.
I think this is, sorry, I just don't see it. 1 moment. sorry, yeah, here we are. Okay, then starting from Dimitar's last point about the need of interdisciplinary research, I'm going to focus on something that needs to be included when working on sign language machine translation, which is the understanding of the structure of sign languages and also of their similarities and differences with spoken languages, because this can help us understanding how and whether we can reuse or adjust or adapt approaches and strategies that have been developed for spoken languages into technology for sign languages. Both sign languages and spoken languages are natural languages, so they are very similar in terms of structure and complexity. However, they use different channels for communication. Therefore, they can differ strongly. And this is reflected in the challenges that we encounter, because some things that we have developed for spoken languages cannot be easily applied to sign languages. And here on the slide, we have 3 basic problems that we encounter. And one is the one about the notation system that Dimitar already described. So I will move to the next 2. Even in the situation that we have a full and exhaustive transcription of a sign stream, we still need to find a way to subdivide this transcript into units. And this is not as straightforward as we might think. And I will talk about it like in a moment. The other problem is that once we have these units, we need to map them to meaning. And this is also not so straightforward. But let's start on why is segmentation difficult? Why can't we just use something like tokenization that we have for spoken languages? And the reason lies in the comparison between signs and words. Because if in terms of grammatical role that they play, and also in the level of organization that they cover in the language structure, signs and words are sort of equivalent, can be considered equivalent. Signs are more simultaneously organized than words. And in addition to that, we have a distinction between the established lexicon and the productive lexicon, as Dimitar just said. And if for the established lexicon, we have a conventionalized form and meaning, so we have a citation form, potentially we could even retrieve the word from a dictionary. For productive lexicon, we do not have that, because these signs are strongly context dependent and exploit basically their form and meaning is shaped during the messages being created. It's like as if for spoken languages, we would invent words all the time while we're talking, and people would understand us without considering them being marked somehow. Yes.
Is that different from morphology in a spoken language?
Yes, because morphology is still somehow conventionalized. Like it is still conventionalized. And yes, we can apply morphology in a novel way to a word, but that would be still marked. Like if I would say,
well, in English, yes, but in like a highly agglutinative language, you get new words, new combinations all the time.
Yes, but still there are more precise rules on how to do that compared to sign languages.
Okay.
In sign languages, it's way more free.
Right. Okay. Thank you.
Thanks. And in addition to that, we also have to consider that we are not talking about a flat structure, but we have different layers of parameters being produced at the same times. In fact, while it is commonly said that the hands usually sign the lexical unit, then there's all the other parameters, the non-manual articulators, that are adding important semantic information to what is being added, what is being signed by the hands. And there has been also quite some research on how we can identify signs and how we can identify their edges, because this is also not as straightforward as it is more or less for spoken languages, at least for the most studied or investigated languages. And most of the studies on sign identification point to the hands as being a clear cue, even though this cue is always combined with other articulators, the non-Manon articulators. And if for the established lexicon, it could indeed be a solution, for the productive lexicon, it's not going to be so easy because we don't have a defined hand shape for a meaning. And the sign edges detection instead is a bit more complicated because there's more cues at play. And to this point, researchers do not even agree on whether signers use the same cues or segment a stream in the same way. Within linguistic research for sign languages, researchers have looked at bigger groups, bigger chunks of the sign stream, namely the prosodic groups, and they've been looking at the boundaries of this, the boundary markers of these groups and the domain markers of these groups. They could identify some of them, but the problem is that there are still many. There's still no evidence for what we know at the moment of specific combinations being the dominant combinations. They have been used, like their presence and distribution has been used to prove that there is a prosodic structure in sign languages. However, they do not seem to be obligatory. So it's still complicated to use this for something automatic because we cannot predict which combination will be there and if it will be there. In addition to that, we have co-articulation and simultaneity. Co-articulation is when a feature spreads from one element to the adjacent one. So it kind of changes the following or the preceding element, and this makes the edges of a sign blurred, because then we don't know exactly, and also we cannot recognize the form of a sign as it compared to when it is in isolation. And then with simultaneity, as Dimitar already said, we can have more meanings combined at the same time, and there can be also extreme cases of simultaneity during which more like two sentences can be articulated at the same time by different articulators. So having all this information occurring at the same time, but not being exactly aligned, makes it difficult to find a way to split the sign stream in a meaningful way. We are currently working on a possible approach to that by using the corpora that we have and that are annotated as Dimitar said, with glosses. And as already Dimitar mentioned, glosses capture some part of the semantics of the sign, and they are aligned with the sign they correspond to in the video. The data that we have is stored in EF files, which is the format of the annotation program tool called ELAN. And as you can see here, glosses are annotated per speaker. Like here you see just it's one speaker, and we see that the glosses here are aligned with some timestamps which align the glosses to the videos. And so these timestamps could be used to learn video segmentation. A lot of work on sign language machine translation with glosses focuses, as Dimitar said, on like predicting glosses. But what we propose here is to just reduce the task to predict the segment timestamps. Currently, we have processed some data using an approach that we developed for for a paper on sign language data challenges. And we have organized the data in video segments, which are aligned with the transcriptions, the glosses, and the mouthing. As such, we want to build a sequence-to-sequence model, which will take as input a video that represents one input in the one input message, and learn which frames in terms of timestamps contain signs and which do not. As input, we are considering using sign and glosses and text. And we plan to experiment with these types of inputs and use either 1, 2, or 3 encoders. The target site is derived from the gloss timing and associated with each frame, which means that each frame is associated with the probability of whether containing or not containing a sign or a partial sign, actually a partial sign. And the neural net will need to learn that. It's still a very much of a work in progress, so any feedback or suggestion is welcome on that. Moving on to segment meaning mapping. We are currently, I need to first say that as we both said, most of the data that is available is annotated in terms of glosses. However, they are not standardized. As you can see here on the slide, you can see that like just few, like here we have only 5 corpora that have different ways of annotating the same thing, which would be the pointing to myself. And in addition to that, the amount of information that is contained in glosses is still limited because it's usually only what is articulated by the hands and not the rest of the information that is produced during the continuous sign stream. So ideally, we would need something that has the information that glosses have, but it also includes the other features, the rest of the information that is being articulated, in order to have some exhaustive description of meaning and form. And at the moment, within the Sign-On project, we are looking into 2 different parallel approaches to that. One is Sign-A with a logical structure. Sign-A is a framework that was developed specifically for sign languages, and it basically describes in a fine-grained manner all the parameters being involved in the sign stream. So everything that the hands are doing, that the face is doing. And then logical structure is derived from rule and reference grammar, which is a framework for describing syntax and semantics of the message. And the second approach we are experimenting with is with abstract meaning representation, and we're planning to connect it with key points. Abstract meaning representation is a framework that has been developed for spoken languages and is a language independent framework for representing the semantics of the message. On these slides, we have 2 examples from the same sentence, which is I accuse you. And in the first example from Sign-A, the part with T-line, MF, which is non-manual features, and so on, is going to contain the information about the form of what is being signed. And the rest is going to be about the meaning. So the rest is the logical structure. Then for the second example, we have just AMR. We don't have key points aggregated with it yet. And we just have a language independent semantic structure, semantic representation rather. Both approaches have some issues we are facing at the moment, and they are different. On the one hand, Sign-A has been developed specifically for sign languages, so it contains potentially all the all the elements to fully describe what is being signed. But we are currently struggling, since it hasn't been used for corpora for annotation of data. We are currently working on possibilities to automatically populate the lexicon with this framework. Instead, AMR, since it was developed for spoken languages, has some data available online. And what we are currently working on is experimenting on how well it can represent the data that we have in corpora by looking at the translations and not the glosses contained in the corpora. And also then we are planning to combine it with the, since here we only have the meaning, we don't have the form, we are looking into how to combine it with form, so with the key points that we could extract from the videos. And that was it. So there's still a lot of work to be done, and we have a lot of work in progress and other projects as well. And thank you.
Thanks a lot for Dimitar and Mirella for the nice presentation. And yes, I think it's a very hard, but a very, very interesting problem what you're working on. So do you have any question for Dimitar and Mirella? I have a couple of questions. The first one is more general. So you are the coordinator of one of the biggest European project on sign language, and obviously one of the problem is data. So are you planning to release any data during the project which can really boost the research on this topic? I know it's a difficult question.
So basically,
sorry, I didn't mean to do that.
It's okay.
No, it's okay. Okay. Go ahead, Dimitar.
Okay, so at the moment we're collecting openly accessible data plus some data that is not publicly accessible. So from sorry, from some private data, like from the broadcasters that we are working with, like VRT, and other things. Also, we are collecting data that some of this data is publicly available. As I said, what we are going to do is we are going to process this data, clean it, and make it more easy for machine translation or other NLP tasks, and we're going to release it. However, other data that is not yet publicly available, it will be very difficult for us as a consortium to release it, because it is very difficult to anonymize such data. So what that will entail is that we'll need really to go to every single person that has been recorded and every interpreter, and then ask for their permission. So again, some data we will release, some data will just not be legally able to do so. With this project, the concept is to have as much possible as open and free. And we are going to release the framework as well as the models that we're going to develop, the data, of course, again, as much as we can.
Okay, thanks a lot. That's important. Also for just replicate the result of the project, I think it's super important.
Yes.
Yeah.
If I may add one thing here, indeed, like data, there is quite some data. There is BSL corpus that is available, DGS corpus that is available. You have limited, and then upon request, you can get more data, of course. There is the corpus entity and other corpora. But the thing is that they are all differently processed and annotated, and that's one of our main challenges. Indeed, that is in parallel with the fact that there is not so much data that we can actually use in terms of how much data is generated, but the main challenge is indeed to put everything in the right format so that we can actually learn from it.
Is this one of the challenge of the project? So this is something you are working on?
That is something that we kind of noticed along the way, and I think that Mirella, she mentioned this paper that we presented in EUREC. Actually, she presented in EUREC this year, which was about the data, and there we outline what are the differences of the different corpora, what processing we had to do in order to put the data into the same or similar format so that we can actually do train some models.
I see. Great. Thanks a lot. The other question, you're a bit out of time, but do you have any other questions? Otherwise, I have one.
Hi, I have a small question. My name is Atul. So I'm not sure. Definitely, Sign-On is a European project. So my question is related to parallel corpora, because are you releasing, will you release parallel corpora in annotated, like through the gloss annotated data, or only just parallel corpora? Are you planning to release? Is this fully annotated or only like parallel text corpus? So similarly, you will release audio and transcribed data. Yeah, sorry.
Well, so there is a lot of the data that we have is transcribed again differently. The main thing is indeed glosses and translation. That's what you have there. And so the data that we are going to release ideally after processing would include this. Some data includes also mouthing and well, you also have glosses of the left hand and the right hand when they sign different things. All this information we are going to collect and we are going to release. So it's not we're not looking to release limited amount of data because, as I said, this data is already publicly available, so you can get this information from the other sources. The point is to add value to this data, right? And I think that by processing this and making it more easily accessible by researchers who are not directly involved in sign language research, that would be beneficial.
Okay. Yeah, because last year we released in lower SMT in fair task Taiwanese and Mandarin. For Mandarin, it's a 128,000 some segment. So, but unfortunately, no participants participated because it's very difficult to build a machine translation. So that's the reason I wanted to know what is your plan, especially and are you including Irish as well, or only for major languages in your project? Are you also including Irish, right? Because
Irish.
Yeah, Irish.
Yeah, the languages that we have are Irish, Irish Sign Language, so British Sign Language, lingua, what is it? LSC? Sorry.
Spanish Sign Language.
Spanish Sign Language, yes. So British, Irish, Spanish, Dutch, and Flemish Sign Language.
Okay, great. So if you want, if you have any comment on my lower SMT data set, you can also see here. So maybe we can discuss later. Thanks. Thank you so much.
Thanks very much for the data that you shared here. I'll look into that.
So do you have any other questions? Because we are really out of time. So no? Okay, so
I have questions, but I don't want to keep people too long, and I don't want to monopolize.
Go ahead, Adam. Go ahead. Don't worry.
Okay. So given that there's so much difficulty in obtaining consistent intermediate representations such as glosses and notations, that seems to me to really argue for an end-to-end system that goes directly from either spoken or text to sign language, or sign language to spoken or text directly. Am I sort of missing some other use for the intermediate representations? Or is the
Mirella, should I answer this? Or
Sure, go ahead.
so one of the main reasons that I see for not still doing end-to-end, although people have been experimenting with that, is the presence of noise in all these videos, right? By doing some sort of pre-processing or sign language recognition, what you do is you get rid of this noise and you focus on the important pieces that are there. And like, for example, if you use MediaPipe or OpenPulse, these are, again, available tools that allow you to do pulse estimation. I think MediaPipe has a model for the face, for the hands, and for the body separately. And so it's really a nice model, nice tool, actually. So if you do that, you actually get rid of all the other part, like background, noise, and you focus on these features that actually contribute to the translation. Yeah, that's one of the reasons to do that, right? To get rid of all these details. Another reason is, of course, to actually look into the segmentation. Because if you do it on a frame per frame, indeed, if you use MediaPipe or whatever models there are for sign language recognition, the models that our colleagues are developing as well, what you do is you do it on a frame base. But then if you do the recognition on a kind of a sign level or based on glosses, then you have, again, reduction of complexity in terms of the length of the sequence that you need to process. So these are two, I think, points that are still, Now,
just the history of speech recognition. I do a lot of speech recognition. That's my field. And sort of the history of it is moving away from that. Just from the very beginning, early in speech recognition, they had systems like that were designed by linguists to try to identify features and use those as to feed into the system for exactly the same reason. And it really, there was a real quantum leap in improvement when we stopped doing that.
I think that we, as in sign language translation, we are still very young to do this quantum leap. There was the work of so one of the authors, I think, is Richard Bauder.
Bauder, yes, he's in UK, right?
Yes, in UK. Who actually, so the paper was published in the beginning of 2021, and there they did sign language synthesis with GANs, so kind of an end-to-end. And okay, it works in a theoretical level, but actually the representation is not clear enough to actually convey meaning.
I hadn't really thought about the other direction of generating sign language. That, I can see that could be quite difficult without a representation.
Yes. Well,
Well, in a text-to-sign language, there are recently papers that show that end-to-end systems are approaching, in terms of performance, the Cascade ones, using glossary as intermediate representation. But they are using a lot of additional external information to pre-train model and to allow the system to have initial knowledge before fine-tuning on existing data.
Yeah.
So,
I hope at some point we are going to get to this end-to-end approach. In our project, it is going to be difficult to do end-to-end because we have so many languages, and if we have to train end-to-end for every language, to be a big mess.
Well, one aspect that can help you is to find a way to generate synthetic data, like people is doing in machine translation.
Yeah, we do have one of the points here was synthetic data, actually, that our colleagues from KU Leuven are working on synthetic gloss generation. So still on that level, so it's not an end-to-end, but we have also spoken about, let's say that we have a way to generate an avatar, and then we can actually generate more sign videos or sign utterances, and then use them on the recognition side as well. But it's a challenging problem, and we are trying to tackle it from very many different aspects: linguistic approaches, neural-based approaches, and hopefully within these 3 years we'll see some results.
So we'll follow the project and your work for sure.
Thank you.
So do you have any other question? Yeah, do you have any other question for Dimitar and Mirella?
Hi, I have a question. Wait, I will turn on the video. So I wanted to ask, which is the best way to represent signs, in your opinion, like to use key points or to use a convolutional neural network, try to pre-training it with another task? Because I did some preliminary work on sign language translation with key points, and it's not working really well, actually. So what's your experience on this?
Again, I think that, so what our colleagues are doing, because I am not trained the sign language recognition systems, they are focusing on key points, sorry. Now, key points, of course, that would lead then to visual embeddings, which visual embeddings or visual representations that you can actually integrate into a machine translation system.
And how do you then transform these key points to something that you can fit to the transformer, for example?
Well, okay, so if you have like a sign to gloss system to train, and then you actually have the key points, you would train a model, and then based on this model, you extract the internal representations of this model. Now, how do you link these internal representations with the system? I guess you can link it to the coder. What you're looking into at the moment is into MBART and trying to align this together.
Okay. Thanks.
You're welcome. Thank you.
Okay, so let me thank about Mirella and Dimitar for the nice presentation, and thanks a lot for being here today. Very nice talk, and I hope you will continue to follow our seminars. Next one will be in October by Jingming Zhao from Australian University, and she will talk about probably domain adaptation for end-to-end speech adaptation. But I will post this information as usual on our mailing list. So thanks a lot, everyone. Have a nice, wonderful day, and we'll keep in touch. Thanks a lot, everyone.
Thank you.
Thank you very much.
Nice work. Thank you.
Thank you very much.
Thank
Bye.
you.